have not graded the exam yet. There's one student who's waiting to take the exam, and as soon as the student takes the exam, I'll grade it and hopefully bring it to you on Monday. Right? Okay.
So the assignments,
Right.
the Monday to get in there?
The assignment that you're working on currently?
Yeah.
Yeah, that's fine to submit it Monday.
Just maybe not all of them. No.
Oh, well, I wouldn't say that. I mean, you'll lose some credit, but even if you're behind, try to submit the assignments. Okay. All right, so let's continue on. So we have covered most of the basic material as far as C# is concerned. So now we'll take a look at slightly more advanced material. Okay. So one of the next topics that I'll describe is called generics. Okay. So the idea behind generics is to make, especially sometimes we write code which operates on a particular data type. So using generics, we can easily make it such that the same code will operate on different data types. So for example, hey, let's say you wrote some a function to swap two integers. So your code to swap two integers will look something like this. Okay. B in temp equal to A equal to B equal to temp. Right? Okay, so suppose you wrote this function in some class, right? So now your test code, the code that will try to call it, might look so in some kind of a button handler, you will do something like this. Okay, int, let's say x equal to 5, int y equal to 7, right? And then you will call swap of x comma y. Okay, and then you'll try to print out the values. So you will, whatever message box that show, let's say a equal to, x equal to plus x dot toString plus y equal to plus y dot toString. Okay, so if we run this program and click on this button, right, and pretend this swap method is also written inside the same form class, okay, what will be our output? What's your guess? Will it be 5 and 7, or will it be 7 and 5?
7.
Okay, if you're not sure, let me describe one fundamental concept. So most of the time in C-style languages, not always, so for example, C++, Java, C#, they all, I refer to these as C-style languages. Okay, whenever we call a method, so calling mechanism is what we call by value. Okay, so what exactly we mean by call by value? Okay, in call by value, what happens is a new memory is created for the parameters. So new memory is created for the parameters. Okay, and then we copy the data from the corresponding parameters into the new memory. So for example, to show you this part, if we click on the button, what will happen if this is the memory of the computer? Okay, there's X, there's Y, right? So the computer will allocate memory for X, memory for Y, will store 5 over there, 7 over there, right? Now it's called the function, right? So take a look over here, 7 corresponds to A. y corresponds to b. So there's a one-to-one correspondence. So this is what I meant, because the default mechanism, so I should say the default. We can change it, but if we don't do anything special, it will do call by value, okay? X corresponds to A, so as I mentioned, new memory is created for the parameters. What are the parameters? A and B in this case. So the computer will allocate new memory for A, new memory for B, because X corresponds to A, we'll copy this over here. Y corresponds to B, so we'll copy the data into B. And then it will start to execute the method, right? So int temp equal to A, so we'll create memory for temp. Temp equal to A, so this will become 5. A equal to B, so this will change to 7. B equal to temp, so this will change to 5, right? Now, as soon as the method is done, the function is done, we lose memory for whatever parameters that we had allocated. Okay, so as soon as this is done, the local variable was temp, A and B were the parameters, all of this is destroyed. Okay, so even though we did exchange A and B to 7 and 5, but as soon as the method ended, we lost this memory. So now if we go to the calling code, what will we find X and Y to be? Still 5 and 7, right? So this is what it will produce, but the purpose of this method was to really exchange the data, right? So in C#, just like in C++, we can use the ampersand to indicate call by reference. In C#, there's a keyword called ref. So if you add this ref keyword, that means we are trying to call these parameters by reference. So what's the difference between call by value, call by reference? In call by reference, okay, we use the same memory. For the parameters. Okay, so in call by reference, okay, now the rule is not only you have to put the ref keyword over here, in the call also you have to put the ref keyword, so that there's no ambiguity. You are indicating that both parameters should be passed by reference. Okay. So how will the memory work out in this case? Again, computer will start out by allocating memory for X, memory for Y, right? Putting 5 over there, 7 over there. Now, again, X corresponds to A, Y corresponds to B, so there's a positional association. Okay. However, now there's a ref keyword. And as I mentioned in call by reference, we use this, we don't create new memory for the parameters. So what the computer will do is temporarily rename X to be A, temporarily rename Y to be B. Then it will start to execute the function in temp equal to A, so it will allocate memory for temp. Whatever is in A, it will copy over here, so this will become 5. A equal to B, so we'll change this to 7. B equal to temp, so it will change it to 5, right? And now, as soon as the function ends, what do we lose? We only lose this temporary association, okay? We can't lose the memory because that was created by the calling code. So we get rid of A, we get rid of B, right? So now if we go and try to print it over here, what will we find?
7 and 5.
7 and 5 in the memory, right? So the moral of the story is, if you want the function to change the parameters, what do you have to do? Call by reference. Otherwise, if you don't want the function to change your data, then leave the default, which is called by value. Okay. So to give you another example, okay, suppose I asked you to write this compute function, and it looks like this: int A, int B, ref int c and something void, right? And suppose you are doing a equal to a plus 2, b equal to b plus 3, c equal to a plus b, right? And suppose you call this function like this. You call the compute by x equal to 3, y equal to 5, z equal to, let's say, 7. So you did x, y, ref c. Okay, see, you don't have to have all the parameters by reference. You can pick which one you want to call by reference, right? So in this case, if I gave you this type of problem on the test, what will be the answer produced if we try to print x, y, z over here?
3, 5.
Okay, see, x and y, even if it tries to change them, will lose that memory, so that change will never be reflected, right? So you don't even have to worry about what it's doing. It will exactly stay the original value, so 3 and 5, right? So now z is by reference, so that will change. So that you do have to figure out. So this was 3 to begin with, so this becomes 5, right?
5 and
8, and then this will become 13.
13.
So z will be
30.
13, right? So anyway, so now that you understand how do we pass something by reference and something by value in C#, okay, so once again, ref keyword is needed to call by reference, both in the method as well as in the calling code, okay? Now next question, or next concept, okay? So suppose you had written this function in, let's say, you created some class, utils or whatever, and you wrote this function, right, inside it, okay? Now, what is this doing? This is exchanging two integers, right? What if somebody, as you were developing your application, not only you needed to exchange integers, you also needed to exchange doubles, okay? So if you also needed to exchange doubles, what will you do? One possibility is you'll just copy and paste this code, right? So you'll copy from here to here, paste it again. So let me pretend we copied and pasted. And you will change this to what? Double. Let's say A, ref, double B. And now what will you say? Double temp equal to A equal to B, and B equal to temp, right? Okay, so first of all, can we have two methods? Both are called swap in a class, right? And what's that called? Overloading, right? What's the rule for overloading? As long as
Type and parameter or
parameter data type is either different or the number is different. So in this case, both are two parameters, but these are integers, these are doubles. So that's perfectly okay. How will our calling code look like if we wanted to call this one? It will look something like this. Double, let's say p equal to 2.5, double q equal to 3.7, and swap of ref p comma ref q, right? So how will the compiler know which swap to call if we put made both calls? How will it decide whether it should call this one or this one, right? Again, it's pretty easy. If you are the compiler, what will you do in this example? So you'll check what is x, right? What data type was x? In. Which one of these takes ins? The top one. So obviously you'll call the top one, right? So there's no confusion. This one will end up calling this one, right? Okay, now let's pretend few days later, after your application is running, you run into a need for exchanging two strings, okay? So then what will you do? Will you copy and paste and change this to a string, string, string? Will that be okay? Will that work?
Yeah.
Yeah, will work, right? What if a few days later you wanted to exchange two bytes also? Can you copy and paste again,
Okay.
right? So as you can see, after a period of time, there will be many swaps, each working on a different data type, okay? So remember we have been discussing the less code we write, the better, it's easier to maintain the application, cost of development is less chances of us running into any problems later, right? So rather than us keep copying, pasting, and keep changing the data type, can we write one method where the data type is flexible, meaning the caller can decide whether it should be int or double or string, right? So those, that capability is called a generics, and it is similar to templates in C++ and similar to generics in Java. However, in my opinion, the C# generics are a lot more powerful than Java, than C++, as I will demonstrate it to you, okay? So how do we write a function which is totally flexible in terms of the data type for the parameters? Okay, this is what we do. When we write it, rather than saying this will be int, see, compare these two. Here, this was int, this was double, right? Int, double. Where else we were making the change? This temp here was int, here was double, right? So once you write two examples of where the data keeps changing, then what you do is you go to the first one and call it some type t. So rather than calling int, make it some t. T is not a keyword. You can choose y, you can choose typ or whatever you feel like it. So pick some, usually people pick letter T because T stands for type, okay? So then what will happen over here? In temp equal to A will become T, right?
T equal to
Why?
Oh, sorry. T temp equal to A, you are right. T temp equal to A, right? Okay, now because T we are indicating is a generic type or a flexible data type, so the other requirement is after the name of the method, between less than, greater than sign, he will type in T. So that means T is a generic type which will be decided by the caller. So as soon as you make this function, now the caller, now we don't need to put the second function. So only one function is needed, that's all, okay? Now the calling code, does it need to change? Okay, for simple methods like this one, you don't have to make any change in the calling code. Automatically what the compiler will do is, once it comes to this part over here, and it recognizes these are ints that we are trying to trigger it with, it will create a copy of this function and replace T with int, okay? A little bit later it recognizes, oh, we are trying to call this function with doubles. So what will it do? Create a copy of this and replace that T with doubles, right? So once again, the benefit is we write one method and it operates on any data type we feel like it. Now, optionally, to be very clear, it is a good practice that once you're calling it, after the name of the function, between less than, greater than sign, indicate the data type. For example, in this case, you will say int, okay? In this case, between less than, greater than sign, you will say double, right? Okay, so this is how easy it is to write what we call a generic method, okay? So see, we can have generic methods just like I showed you the swap method. We can also write generic classes, okay? So now let me give you an example of a generic class, okay? So to give you an example of a generic class, okay, suppose you created some class XYZ, okay? Suppose one of the data types is int A, then you wrote public int A get return A set A equal to value, right? And very similarly, you created one more int B, and then public int B, and then get return B, right? And whatever the rest of it is. Okay, and you may have some other things over here, right? So let's pretend sometimes you wanted the A field over here to be integer. Sometimes you wanted the A field to be double. Sometimes you wanted it to be a string, right? So rather than keep creating one more class, and you may call it XYZ2 or XYZ3, and keep changing this data type, right? So meaning doing something like this, XYZ2, and then saying double A and so on, right? And then double B and so on. Okay, then creating XYZ3 with a string. So if the data or the fields inside the class keep changing, this is where we create a generic class, right? So just like a generic method, after the name of the method, we indicate the flexible or the generic data type. Very similarly over here, after the name of the class, we indicate the generic data type, okay? Now, how many data types are there? What if we wanted the flexibility that this could be an int, this could be a double, or this could be a string, this could be a byte. So we wanted to give complete flexibility. So because we have two fields, each can be different, think of it as if we have two flexible data types or two generic types. Okay? So since we have two, let's call it T1 as one type, T2 as the other type. Okay? So now instead of int, what will I say over here? T1. Instead of int, what will I say over here? T1, right? The rest of it stays the same. What about over here? T2, and then T2, right? Okay, so, and now there's no need to write this. So now how will the caller decide that A should be an int, B should be a double as an example, right? So let me show you the calling code now. Okay, so the calling code will look something like this, XYZ. Okay, now because XYZ is a generic class, right? After the less than sign, the caller has to decide what should be the data type for T1, what should be the data type for T2. So if we wanted A to be int, the caller will say int over here, comma. If the caller wanted B to be double, so the caller will say something like this. Then x1 equal to new, xyz, same thing. Int, comma, double, and then left paren, right paren. So the extra part that's getting added is basically the less than greater than sign and the actual data type that we wanted the two fields to be, okay? Or the two generic parameters to be. So invoking a generic class requires an extra specification. If it's a non-generic class, we will simply say like this, right? New XYZ. But because XYZ is a generic class, we have to indicate what should be T1, what should be T2. So that's the extra part that's coming over here when we create an object of the class, right? Okay, so now, so this was an example of a generic class. Okay, swap was an example of a generic method, right? Okay, so now,
So over there, like you wrote T2B and T2 again that B. If we know that it is int, so we can just use T1 over there.
if A was going to be always in,
No, even B is always in. So
No.
can we use T1 over there?
if B field was always going to be in, then you did not want it to be a generic. Then you will simply say int B, public int B.
Can't we use T1 or T1 over there?
No, because T1, remember the caller can, if the caller put a string over here, then T1 will become string as an example. So if you already knew, no, A cannot be, A will always be an int as an example, then you will not make that a generic.
But suppose we know that A and B will be of the same data type, then we can use T1 for both.
Correct, then you will use T1 for both, exactly. Okay, so, so the question is, this example made sense, right? That we did not want overloading, we did not want to keep overloading the swap for int and double and string and so on. But this example may not make perfect sense yet. I mean, it's our toy example. So the question is, in real life, where do we use generic classes, right? To give you an example, a lot of our data structure classes. Okay, you guys remember from your data structures classes, let's say you wanted to create a stack. Okay, remember what kind of operation stack has? Push, pop, whatever, initialize, and so on, right? Okay, so what if you wanted to create a stack of integers? So if you did a push 5, 5 will go on the stack. You did push 7, 7 will go on the stack, right? Okay. So what if you wanted a stack of strings? Okay. So rather than creating a class where the data type of the storage keeps changing, what if you wanted to create a stack of students, right? Class object. So as you can see in this situation, if we created the stack as a complete generic class, then the caller can say, create a stack of int, create a stack of double, right? Same thing for queues, stacks, queues, lists, and so on. The caller can then pick what data type it should be, and so we don't have to keep copying the class and creating another class name for a different data type. So that's the advantage, right? So let me give you a few examples now, practical examples, where this will be very useful. Okay, so if you take a look at generics, by the way, in the beginning they are a little bit intimidating because you see, oh, what's this T over there doing? What's this T1, T2 doing over here, right? In my opinion, the easiest way to develop a generic class or a generic method is don't worry about generics, okay? If somebody asks you to write this method as a generic, okay, start out by picking one data type. So just assume, oh, what if I wanted to create a swap for integers, right? So how will I write it? Swap, I mean ref int A, ref int B, right? Then int temp equal to A, and so on, right? Okay, then write one more method for a different data type. So ref, of course, this will become double, right? Ref double, and double temp equal to, right? As soon as you have written two examples of two data types, now it's very easy for you start comparing, oh, this one was changing. So that means I should change this to, I should change this to T or T1 or whatever. In this case, there's only one data type, so T, right? This will become T, and this will become T. So it becomes very easy. And because we picked this to be T, then further after the name of the function, you'll put T over there, right? So all I'm saying is, don't be intimidated by the fact it's a generic. Create two real examples of two separate data type cases, then it's very easy to convert to a generic, okay? So now let me give you slightly more interesting examples and so on. Okay, let's take a look at an example of creating an array of reference types. Okay, if you recall, we had discussed that array itself is a reference type, right? So for example, if I asked you to create an array of 5 integers, int is a value type, so creating an array of value types is easy, right? What will you do? After the data type, if you put empty brackets, what does that mean? That means it will be an array. Then you give it some name, right? Because arrays are reference types, the memory for the array has to come from the heap, right? So then you will say new int of 5 as an example, right? So right away it gives us 5 memory locations. A0, A1 through A4. Now it's easy, you can do A of 2 equal to 5. So in location 2, you'll be able to store 5, right? Pretty easy. Okay, but if you recall, I had mentioned creating an array of reference types is tricky. It's a two-step process, okay? So this is a two-step process. Okay, step 1 is you have to create an array of references. And step 2 is you have to allocate memory for each reference. All right, let's take a look at an example. Okay, suppose we have a student class, okay, and we wanted to create an array of students. Okay, so what will you do? You will say student. Since we wanted to create an array of students, we have to put empty brackets after that, correct? Then you will pick a name for the array, right? Let's call it S array equal to new student of, let's say 5, correct? So what will this do? If we try to do after this, if I try to do something like this, dot first name equal to Bill, will this work?
No.
Okay. If you go to the computer, try running it, you will get a null pointer exception, okay, or null reference exception. Okay, and the reason is because there's no memory for the first name. I remember what did the first line do over here? The first line simply created an array called S array, right? So that's a reference. And then in the heap, we allocated S array of 0, S array of 1, okay, and so on, S array of 4, However, these are pointing to nowhere. So this is like a single memory for each reference, but each student has 5 fields over here, let's pretend. So the memory for the 5 fields does not exist yet. So that's why if you try to do this right away, you will get a runtime error because there's no memory to store the first name, right? So then if you recall, the way we allocate memory for each student for each reference in the array is we often write a for loop. For int I equal to 0, I less than s array dot length I plus plus, and we will say s array of I equal to new student. Okay, so now in the heap area for 1 by 1, this will get 5 fields. Then this will get its own 5 fields, and so on, right? So now if we try to write it over here, it will be perfectly okay. Okay, so now what if we wanted to write a generic method so that it can create an array of any reference type? Okay, so let's take a look over here. Suppose we wanted to call this method void init array. Okay, and int size. So we wanted to pass it a size, and it will create the array, right? Okay, so now if we take a look over here, how will we change this code? So if I clean it up a little bit. Okay, so all of this is inside the method, right? So what will this 5 become now?
Size.
So this will become size. Okay, then rest of it will stay the same, correct? So this will be just one method, which if somebody called it, let's say init array, actually it should return, let's do this. It should not return void. It should return an array of students. Right? So this is what the method will look like. If somebody calls init array, gives it a 5, this will create an array of 5 students, create the memory, and return the reference to it, correct? So how will the caller call this function? Okay, the caller will call this function something like this. Student, let's say S array or SD array, but let me give it some other name. So let's call it SDA equal to init array of 5, for example, correct? And now this will create the memory and give it to us. Now let's pretend you were creating a large application where you have students, you have part-time students, you have graduate students, and you needed to create an array for each one of those, right? So now let's create an example. Remember, like I was saying, create 2 examples, then you can easily convert it to a generic method, okay? So let's create the example for, let's say, a grad student. How will this code change?
Grad student.
So you will say grad student init array in size. Okay, and again, grad student. Let's call it G array or S, or let me leave the same name because it will be easier to change it. Okay, so if I say S array equal to new grad student, in this case size, correct? Okay, and then the for loop, correct?
Yeah.
For, and then the only difference is it will say S array equal to
New grad student.
new grad student. Correct? Okay, so now that you have written 2 examples of it, like I said, what if in your application you wanted to create an array of employees, an array of managers, and so on? So you can keep copying and pasting and keep changing it. It will work. By the way, if we wrote both of these methods in the same class, will it be acceptable?
No.
Why not?
Parameter. and
Name
type
is
and
the
set.
same, and the parameter is 1, both are in, so it will not even let you overload, correct? So what would be your choice if you did not want to use generics? Instead of overloading, you will call it init array, let's say grad, you will call it init array SD or student, right? Okay, so again, you can make it work, but that's not a clean solution, right? So we want to write as less code as possible. So now let's try to convert it to a generic. Okay, so what keeps changing over here, as you can see,
Type.
this keeps changing. So now let me change this to type T. Type T. Or I'll just change it up there. Let me leave this as grad student as an example. I'll just change it at the top. Okay, so if this is type T, right, then what does that mean to me? Because the init array function will operate on type T, then after the name of the function, what do we have to do?
Placeholder.
We have to indicate that T is going to be our flexible type, right, or the generic type. Okay, now let's go to the next line. What will this change to? Wherever student is becoming T now, right? And then S array equal to new T. And then let's go to this line. Int I equal to 0, I less than S array dot length, S array equal to new T. And you have your generic method. Now, how will the caller call it if they wanted to create an array of 5 students? Okay, let's take a look at the calling code. So, so the calling code will look something like this now. Student, let's say SD array equal to init array. Okay, now remember, as I mentioned, it's a good practice to be explicit in the calling code. The calling code decides what should be the type T. So because after the name of the method we have type T, so what should I say over here? Student and 5. So this will give me an array of 5 students. What if I wanted to create an array of 10 graduate students? What will it look
Grad
like? Student, let's say GST array equal to init array, and then in the parameter I will say grad student and say 10 over here, correct? So that's how easy it is to create generic methods, okay? Now if you go home and try running it, you will notice this code will not compile, even though what I described made sense, okay? The reason it will not compile, and this is where C# is a lot better than Java and C++ in terms of generics, is because what if somebody tried to call this method like this? They try to call it like this, int, let's say A equal to init array of int 5. What will happen? If somebody triggered this generic method that we wrote like this, okay, take a look over here. T is what now? Int, right? So int s array equal to new int, so which is fine. So this is perfectly okay. Now we go over here. Int I equal to 0, I equal to s array dot length, for example 5 in this case. S array of I equal to new int. But there's no such thing as new int. It's a value type. We don't trigger the constructor for an int, right? So this is where it will fail. So C# is very good about if there is a possibility that somebody can trigger it in a wrong manner, it won't even let you compile the code. Okay? So when we write generics, especially as it's slightly more involved situation, then we also have to provide constraints. Okay, so gradually I'll introduce the constraints to you, and you'll see they are very easy, very neatly designed so that you don't have to remember anything. It will make complete sense. Okay, so what was the problem over here in this example? As you saw, the problem was this line over here, that for a value type there is no constructor, right? Because we are triggering this constructor, right? Anytime we say new student, left paren, right paren, aren't we triggering the constructor, right? So the requirement over here, as you can see, is that the type T should provide a constructor. Otherwise, this code will not make sense. So if I rewrite this properly, which will work if you go home and try it on a computer, the proper init array will look something like this. T init array. It's a generic type T in size. Okay, and then we will put a constraint before we write the actual code. Now this is how we specify that constraint, where T new. Okay, then so basically that all this means is that T should provide a constructor. If it did not provide a constructor, this code cannot be called. Okay, so this is our first example of a constraint. Okay, and the rest of the code stays the same, meaning T s array equal to new T of size, and for int I equal to 0, I less than s array dot length I plus plus, and s array of I equal to new T. So now this is our proper generic method with constraints. Okay, so now let's go over here. Suppose you wrote this function. Okay, so you trigger it this way. Will it work? Okay, it will work as long as what? Student has a constructor. Okay. Remember, if you created a class called student, suppose you did not write a constructor. You just created the 5 fields. Then will this work? Okay. Remember, if you don't write a constructor, you always get a default parameter-less constructor. So the answer is yes, it will work. Okay. What if now you created the student class and you provided a constructor, let's say public student, let's say whatever, string FNM and so on. Okay. and you initialize the 5 fields over here, right? Now will it work?
No, I should provide the default constructor.
Correct. Remember, if you, the minute you provide your own constructor, C# takes away the default constructor. So now, as it tries to do new student, there is no student constructor without any parameter. So now this will generate an error. Okay. So the code won't even compile. Okay. So that's the good news. Okay. So anyways, what about this line? If somebody tried to trigger this generic method, will it work? Why not? Int does not have a constructor, right? Okay, so anyway, to summarize, what I'm trying to show you guys is generics make our life extremely easy. So in fact, if you take a look at, and especially as we go along, we'll be using generics a lot. As you take a look at a lot of the more involved C# code, you'll see it heavily uses generics, okay? Again, because we can generalize our code, we don't have to keep redoing if the data type changes. Okay, and next thing is don't be intimidated by the generics. So if I showed you this right away without explaining everything, you'll get confused. Oh, what's this T over here? What's it doing over here? And once again, the way I develop any generic code is I don't even worry about the generics. So after I've written a real example of 2 cases, then it's very easy for me to see, oh, this is how I need to generalize, and it's very easy to do that. Okay? So go one step at a time, create 2 concrete examples, then you can easily write the generics, right? Okay, so now let me show you a slightly more involved example. Let me just double check what time we have. Okay, we have 10 minutes. Okay, but to clarify some of the constraints, let me give you a simpler example. Okay, now suppose you wanted to write a method which will take the average of the data inside an array. Okay, so so your method may look something like this: double compute AVG. Okay, and let's say some data. Okay. Okay, so what will your code look like if you wanted to write? So you'll do something like this. Double, or let me make it a little more interesting. No, I think that should be okay. That should be okay. So double sum equal to 0 for in I equal to 0, I less than data dot length, I plus plus, right? And you will do sum equal to sum plus data of I, correct? And then return sum divided by data dot length, correct? Okay. So in this case, it's producing the average of an array of integers, correct? What if sometimes you needed to compute the average of an array of doubles, right? So once again, let's create another example before we convert it into a generic. So what will it look like? Compute AVG double beta, right? And will any of this code change inside it?
Yes, we should change it to double.
Which one?
No.
Oh, no, that's
Nothing.
so,
Nothing.
So it stays the same, correct?
yeah, it's the same.
Okay, now can we convert it to a generic? Okay, so if we convert it to a generic, what will it look like? this int keeps changing to a double, right? So what will you do now? Make this type t. Because do I need to change any t over here? No. So then, because this is the flexible data type, what should I say after the name of the function? Between less than greater than t, right? Okay, so now there's a small problem over here, okay? How will somebody trigger it if they wanted to compute the average of an array of integers? Okay, they will do something like this. Double AVG equal to compute AVG, and after the name of the method, they'll say int, correct? And suppose they've already created an array int a equal to new int of, let's say, 5. And then they've initialized the array. Let's pretend, right? So compute int of 8, correct? And this will give them the answer, okay? What if they wanted to, they created an array of doubles? Okay, so then how will they call it? Double AVG2 equal to compute AVG, and over here it will be double, right? Everybody agrees? Okay, so now do you recognize a problem? What if somebody created an array of students and called this function, right? So if I suppose I trigger my old generic method over here, the init array, correct? So if I did something like this, st array student equal to init array student, let's say 5, correct? And then I try to do double AVG3 equal to compute AVG of student, and pass it the st array. Okay, what will happen? So we'll come over here, right? T will be what now? Student. So sum plus, how can we add a student to a double? So it doesn't make sense, right? So what's the constraint that we need in this case? See, previously we said that it has to be, the data type has to provide a constructor, right? And which data types have constructors? Classes.
Yeah.
So in other words, when we said where T new, essentially we meant type T has to be a class. Otherwise you cannot call the init array, right? So what should be the type T over here? Can it be a class?
Primitive data.
It has to be one of the value types, primitive data types, right? So anyway, so just like we have a constraint for a reference type, the constraint for a value type is T struct. So that's how they designed it. So in this case, you will indicate only a value type can trigger it. So if you try to trigger it through a student, this code will not compile. Okay, so will not compile. Okay, so let me do this. Let me stop at this point, and the next example is a little more involved, so I won't be able to finish it, so I'll describe it in the next lecture. There is a handout on generics where I do have these same examples that I went through it. Please go through it. And again, my suggestion is, just in case you did not do well in the first test, we will have a final. It will be more involved, But the only way to learn programming is by sitting in front of the computer and trying it, okay? No matter how much you understand it, you will not be able to do well on the test if you don't go and program 2-3 hours every day, okay? So please go home and try it yourself. Make sure you feel comfortable. Anyway, let me stop at this point.